Welcome back to AI Unpacked. Today, we're diving into a fascinating paper titled The Unseen Adversaries Robust and Generalized Defense Against Adversarial Patches.
Ooh, unseen adversaries sounds a bit spooky. What exactly are adversarial patches? And why should we be worried about them?
Good question. Imagine a small sticker or patch placed on an object. This patch is designed to trick AI systems, like those in self driving cars, into misidentifying things.
So, a car could see a stop sign as a yield sign just because of a cleverly designed sticker? That's genuinely concerning for safety, right?
Exactly. And this paper adds another layer natural noise. Think of blurry images or static, like Gaussian or salt and pepper noise. These are common in the real world.
So, we have these malicious patches and then everyday image imperfections. Why is it important to study them together? Haven't people looked at them separately?
Well, that's the key gap this research addresses. Most studies looked at patches over noise. This paper, for the first time, combines both to see their joint impact.
Combining them, does that mean they had to create a whole new dataset to test this out? That sounds like a lot of work.
They did. They built a singularity dataset using ImageNet and COCO images. They applied 10 different adversarial patch styles and 3 types of natural noise.
Wow. So we're talking about thousands of images with various combinations of patches and noise. That's a comprehensive test bed for AI defenses.
Indeed. For detection, they extracted features using deep neural networks, specifically VGG and vision transformers, or YT. These are like the eyes of the system. Uh,
Okay. So features are extracted. What did they use to actually classify whether a patch or noise was present? Was it more neural networks?
Surprisingly, no. They use traditional machine learning classifiers like support vector machines, ADA boost, and random forests. Why? Because they can be less susceptible to noise.
That's a clever approach. It's like using a different tool for a specific job rather than just throwing more deep learning at the problem, right?
Precisely. Now, for the results. They found that combining patches and noise significantly degrades model robustness. It's much worse than just a patch alone.
How much worse are we talking? So, if a patch alone drops accuracy by, say, 50%, what happens when you add noise? Does it just completely break the system?
Pretty much. For some CNNs, like RESNET 18, accuracy dropped from 76% clean to just 3.4% with patch plus Gaussian noise. That's a huge drop.
That's terrifying. Were there any models that showed more resilience against these combined attacks? Or was everything equally vulnerable?
Good question. Transformer based architectures like VIT actually showed much higher resilience. They retained more of their robustness even with combined attacks.
So, YT models are proving to be more robust. That's a crucial insight for developing future defenses, isn't it? What about detecting these attacks?
Yes, absolutely. For detection, they looked at seen patches, those the model Tridon, and unseen patches, which are completely new to the system.
Okay, so for seen patches, I imagine detection is pretty good. But for unseen ones, that's where the real challenge lies, right?
Spot on. For seen patches, VGG with ADA boost was almost perfect. But for unseen patches, YT combined with an SGD classifier real shone, showing strong generalization.
That's a practical takeaway. So, if you know what patches to expect, use VGG plus ADA boost. But for real world, unpredictable threats, YT plus SGD is the way to go. Very practical.
And here's another important point the YT plus SGD combination also showed high resiliency when unseen natural noises were added to the unseen patches. It's a dual defense.
That's incredible. Did these findings also apply to other AI tasks, like object detection, which is critical for things like autonomous vehicles?
Yes, they did. The combined patch noise attacks also significantly degraded the performance of state of the art object detectors like YOLO. It's a widespread vulnerability.
This paper really highlights the need for robust, unified defenses in AI. It's not just about one type of attack, but the complex interplay of multiple unseen adversaries in the real world.
They plan to expand the dataset with more manipulations and develop a novel attention guided self supervised patch detection algorithm as a unified solution. Exciting stuff, Factorial.
Absolutely. This research by Kumar et al. Is a crucial step towards making AI systems truly reliable in our messy, unpredictable world. It's about building trust, one robust defense at a time. Thanks for unpacking this with me.